Hello everyone, good morning. Dear authors and invited guests, welcome to Technical Session 7C. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information, Communication, and Technology for Sustainable Development, ICT4SD 2024, Goa. The 9th edition of this conference was organized in hybrid mode. The physical event is organized was yesterday in Goa, and the digital is today and yesterday. It means 8th and 9th August 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder so that you can conclude your presentation. There's another request for all the participants that you may please stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. Further, if you have any query or any doubt, you can write it to me directly in the chat box. So just before we get started the session, I'd like to introduce you all to the chair for the session, Dr. Sanjeev J. Wagh. Dr. Sanjeev Wagh is currently the professor and head of department of Information Technology at Government College of Engineering, Karat. He is member of IEEE ACM, the Institution of Engineers, India, International Association of Engineers, IANG, Hong Kong. His research interest includes advances in networking, design, and analysis of computer network, mathematical modeling, internet routing design, network and information security, advanced computer network. I request, sir, if you have any remarks for the chair, for the presenters.
Yeah, very good morning, one and all, and hope the session will be very fruitful to the society, community, and the researchers. And please start the session, sir.
Yes, sir. Okay, so now moving forward for the first presenter. First, we have Brinda Ghosh, and she is going to present on a blockchain-based e-voting system for secure and transparent elections. The presenter, you may please start your presentation.
Hello, sir. Good morning, sir.
Good morning.
Sir, can I start after 10 to 15 minutes? Actually, there is raining outside, so I have encountered some networking issue actually here.
Not
So,
an issue, then we can
yeah.
move for next presenter. Next, we have Sanjana Kumari, and she is going to present on a comprehensive analysis of pre-trained NLP models. Sanjana, are you here?
Yeah, I'm here.
Yes.
Let me share
You can
my
start
screen.
your presentation. Yes, please.
Yeah. Oh, is it visible?
Yes, it is visible.
Okay. So, good morning, everyone. I am Sanjana from Indira Gandhi Delhi Technical University for Women, Delhi, and my co-author Nandini from the same college. Our paper ID is 274. Our paper title is A Comprehensive Analysis of Pre-trained NLP Models. So, natural language processing, as you all know, is vital in today's digital landscape, which helps empowering virtual assistants, sentiment analysis, language translation, and many more. A pre-trained model is a deep learning model that has been trained on massive data sets to complete a particular task. Our project aims to compare transformers models across tasks. The tasks we choose are question answering and summarization. So basically, we have evaluated multiple pre-trained models and compared their performance in terms of accuracy, efficiency, and usability. And finally, identified the strengths and weaknesses of the models. The first paper we reviewed assessed the suitability of pre-trained biomedical language model like BioBird for biomedical question answering by fine-tuning them on specific biomedical datasets. The second paper investigates the effectiveness of LLMs like GPT-3 on a project-specific dataset, showing they outperform current models using few-shot training using the GPT Codex model, but faces challenges in their applicability in real-life scenarios. In the third paper, the authors present a survey on language representation learning, focusing on four perspectives: task types, representation types, architectures, and extensions. They reviewed the development of pre trained models, their applications, benefits, and challenges. Research gaps. Firstly, we must address ethical and practical considerations in real world applications. Many studies overlook these aspects, and it's essential to ensure LLM deployment is ethically sound and feasible. Secondly, optimization and fine tuning need more exploration. We should focus on enhancing LLM effectiveness and performance with cutting edge methods. Thirdly, we need to improve interpretability and explainability. Making models more transparent will build user trust and understanding. Fourthly, thorough evaluation and validation are crucial. We must assess LLM effectiveness, security, and safety in real world scenarios. Lastly, we should explore generalizability and transfer learning. It's important to determine if LLMs can adapt to various domains and new tasks effectively. Addressing these gaps will advance the field and ensure responsible, effective deployment of LLMs. Our methodology involves selecting a diverse set of pre-trained transformer models. We then curated datasets specific to each task. By inputting task-specific data into each pre-trained model, we rigorously evaluated their performance using established metrics such as accuracy, F1 score, and row score. Through systematic comparison, we aim to identify the most effective models for each task and gain insights into their strengths and limitations. Our first task, question answering, focuses on providing accurate and relevant answers to questions posed in natural language based on the given context or knowledge. The models which we used are BERT, Distilbert, Roberta, and Tiny Roberta. Next task was summarization, in which a short and precise summary of a piece of text is generated. One can use language models and LLMs to summarize news stories, scientific articles, technical papers, and various other kinds of text. The models we used are BART, Big Bird, T5, MT5, and LED. The performance of question answering models is analyzed as shown in the table. The analysis indicates that BERT and Distilbert achieved the highest accuracy and F1 score, both scoring 96.5% in accuracy and 93.5% in F1 scores. Roberta and Tiny Roberta followed with slightly lower scores, with Roberta scoring 89.6% in accuracy and 81.2% in F1 score, and Tiny Roberta scoring 93.1% in accuracy and 87.1% in F1 score. Overall, BERT and Distilbert demonstrate superior performance in accurately generating relevant answers to questions, while Roberta and Tiny Roberta exhibit competitive but slightly weaker performance. As for summarization, BART and LED model demonstrate the highest accuracy scores of 99.1% and competitive row scores across all metrics, indicating their superior performance in generating concise and informative summaries. T5 also exhibits strong performance with an accuracy score of 97.6% and competitive row scores, suggesting its effectiveness in text summarization tasks. Big Bird Pegasus and MT5 show lower accuracy and row score, indicating comparatively weaker performance in generating high quality summaries. We have evaluated models such as Distilbert, BERT, Roberta for question answering, and MT5 BERT, BART, Big Bird for text summarization based on criteria like accuracy, efficiency, and suitability for various domains. For faster inference speed and where we can compromise fewer percentages on prediction metrics, we prefer digital bird. For best prediction metrics, use Roberta. If there are no critical needs like speed or etc., then use Google's BERT model. Coming to future scope, further experiments can be conducted on to fine-tune pre-trained models on domain-specific dataset to enhance their performance for specialized tasks. Secondly, it is essential to continue monitoring advancements in pre-trained NLP models. By incorporating newer models, we can engage in ongoing comparative analysis and improvement, ensuring that we stay at the cutting edge of the field. Thirdly, we must optimize these models for real world deployment. This includes ensuring scalability to handle large data sets, which is crucial for practical applications. Lastly, incorporating multilingual capabilities is a significant future scope, exploring how pre trained models can be adapted and optimized for diverse language tasks and datasets will expand their utility across different languages and regions. So these steps will drive the continued evaluation of LLMs, making them more powerful and versatile tools for a wide range of applications. Thank you.
Thank you, dear presenter, for presentation. Sir, is there any question for presenter? There's no question. Okay, so moving forward for the next presenter. Brenda, are you ready for presentation? Brenda, are you ready for the presentation?
Just 5 minutes. Just 5 minutes, sir. Just 5.
Okay, then move. We are moving for next, and then after we can. Okay, so next we have Manjunath as Chaval, and he's going to present on AES CBC 128 implementation on resources constraint for platforms, case study on Raspberry Pi and Cortex-M. Dear presenter, you may please start the presentation.
Hello,
Yes.
it's Tejas here. The Manjunath is having a bit problem with his mic actually.
Okay.
Can he present a bit later? Like he will solve the issue and he will just present.
All right.
Yes.
So moving for the next presenter till then, V. Shebu, and he's going to present on Beyond DNS Poisoning, HTTP/3 request forgery through packet data tampering. Dear presenter, are you here? Seems so he's not also here. Till then, moving forward for Suraj Gade, and he's going to present on customer segmentation and purchase prediction system.
Good morning. Hello. Am I audible?
Yes, you're here. You're audible.
Okay. I'll just share my screen. Is my screen visible to everyone?
Yes, it is.
Okay. So this is the presentation. So good morning, everyone. And the project that I created is customer segmentation and purchase prediction system. The main goal of this project was to create a free open source and a stack of different modules that would provide us business, whether it is a small scale business or a large scale business, with the tools to analyze their customers. Our paper ID is 351. So, so to give you a brief introduction about the project that I created, there are two main modules. The first main module is the customer segmentation part. The customer segmentation is basically dividing our customers into various groups. Various groups would share some similar characteristics. And the next module is purchase prediction. Purchase prediction is analyzing the demographic or the purchase pattern of the customers and then predicting what would be their future purchases or how would their behavior in the future would be like. This is the literature survey that we did. And uh, this is the architecture of our application. It is a pretty complex architecture. That was the main goal uh, of creating this project. It was we wanted to create a complete system which would be free and open source for various businesses. So in this application, we can see there are various modules. These are the total 6 modules that we have created. The first one is RFM segmentation module, and the next one is churn prediction module. These 2 modules are for segmentation that use artificial neural network for creating various segments among the customers. The next 2 modules are for visualization or exploratory analysis. This is multi-attribute segmentation module and the visualization module. And the next 2 modules are for prediction of the future purchase prediction of the customers. So this is how the application looks like. On the left hand side we have all the modules available, and on the right hand side we have some basic uh, instruction on how to use the application. Okay, the first module is multi-attribute segmentation module. In this module, we segment customers basis on some attribute or some demographic information like their graduation or their age or their profession or their spending score. The next module is visualization module. In this module, we visualize customers on the basis of their demographics, like their gender, age. We draw some uh, pie chart. We draw some graphs like pie charts, heat maps, scatter plots, etc. These 2 modules are only for the exploration of the customers, like how the customers are distributed in the business. The next module is RFM segmentation module. This is the one of the most complex module in which we have used an artificial neural network to create to segment the customers and add labels to them. Uh, the labels that we added are like this. For example, the result the artificial neural network gives us is the for each customer it would predict which label it belongs to. For example, the labels are lost customers, best customers, uh, the customers with the most involvement in our company. We can find out with this model, with RFM segmentation model. RFM basically means recency, frequency, and monetary value. Recency means how recent the interaction of the customer was with our business. Frequency is how frequent the customer interacts with the business. And monetary means how much monetary value does the customer bring to our business. So using these 3 matrices, matrix, we created this neural network for prediction of various for segmentation of the customer. In this module, we can also uh, uh, visualize the distribution of various customers on the geological scale. This was the performance that our model provided. Initially, the model gave us the accuracy of 93%, but we due to overfitting we had to reduce it, and now we have a stable accuracy of 88.83%. Moving on to the next module. The next module is churn prediction module. In the churn prediction module, we predict whether a customer would churn or not. To churn means whether he would continue to interact with our business, or would he leave, stop interacting with our business. So this module also uses artificial neural network. This is a binary segmentation problem, binary classification problem, and in this we can see in this data frame, uh, for each customer we segment it basis on whether he would churn or not. We also draw some graphs to visualize the churn prediction. This is the accuracy that our model, that neural network gave us. It gives us a stable accuracy of 85%. And the next module is customer behavior analysis module. It is one of the most important module because this module shows us insight about how the customers interact with the business, or what are their behaviors. For example, in the behavior features we can see that what were the average days between purchases, and what are the cancellation frequency, when was the customer most active, on which day of the week, or which hour of the week. This module gives us the behavioral features of the customers, and it also provides us with the market basket rules, association rules for uh, identifying features which can be later used for cross selling or upselling of the products. The next and the last module of our application is the prediction module. In prediction module we can directly input the products that are bought by the customers, and the application uses the market basket analysis along with the item based collaboration filtering to predict which uh, which products the customer is most likely to buy in the future. And it also provides us with the confidence. For example, if a customer purchases these two products, then the application would predict which product he is most likely to purchase. For example, the application told us that he would purchase this product with the confidence of 90%. Okay, that was all about the application part. Uh, okay. So to summarize, the RFM segmentation and churn prediction part uses artificial neural network. The multi-attribute segmentation and visualization part uses basic data analysis and exploratory analysis for showcasing or for visualizing the customers. And the product analysis and prediction uses data analysis, exploratory analysis, market basket market basket analysis, and item based collaborative filtering to predict the behavior of the customer and which products he is most likely to purchase in the future. The application also uses caching to cache the data so that it can be easily retrieved. We have created a system which can be which is very scalable. It can be used directly by the business, where there are very heavy traffics, where there are lakhs of customers. uh, it can be directly integrated or plugged into their system, and that was the main aim of the application, to provide it free and to make it free and open source. uh, Thank you. That would be all from my side.
Thank you, Suraj, for your presentation.
Thank you. Thank you.
Is there any question for the Suraj? Yes, but there is no question.
Okay,
Moving
thank you.
forward for the next presenter. Yes, thank you, Suraj. Moving for the next. Next, we have Sai Desai, and she's going to present on enhanced communication security delivered in quantum cryptography. Sai, are you here?
Yes, good morning, sir. Am I audible?
Yes, you are audible.
Let
Please
me-
share your screen and start your presentation.
Is the screen visible, sir?
Yes, it is visible.
Yes, so good morning, all of you. I would like to present my paper, Enhanced Communication Security, Leveraging Quantum Cryptography. Let me just give you a quick overview of the paper. In this paper, we delve into the foundations of quantum computing, focusing on the principles of quantum mechanics. Then we have a literature survey summarizing the advancement and challenges in quantum computing. We explore QKD protocols like BB84 and E91. Then we examine various cyber attacks that pose threats to communication system. And a proposed system integrates quantum key distribution with symmetric encryption. The concept of quantum computing first emerged in 1982 when Paul Benioff proposed a machine that operates using the principles of quantum mechanics. In 1982, Richard Feynman expanded on this idea, suggesting that quantum computers could simulate quantum phenomena more effectively than classical computers. Quantum computers are a reality now, and they use qubits which exist in a state of superposition, representing 0 and 1 simultaneously. This unique property allows quantum computers to process vast amount of data concurrently. The key component in quantum computing is quantum gates, which manipulate the state of the qubit. Unlike the classical system, in NOT gate, it inverts the state of our qubits, which is gate 0 to gate 1. The second is control NOT gate, which flips the state of target qubit based on the state of the control qubit, which creates an entangled state. The third one is the Hadamard gate, which transforms the qubit state in an equal probability of 0 and 1. Basically, it creates a state of superposition. So this is a literature survey which highlights the methodology, advantages and disadvantages of paper which discuss quantum key distribution. So let us discuss about the QKD protocols. The first one is the BB84 protocol. It uses random selection of qubit states for secure key generation. So Alice and Bob are the two communicating parties. Alice selects random bits and encodes them into photons using different polarization states. They are straight or diagonal. Then, if the basis of both the communicating parties match, the measurement results are appended and the final key is generated. The next one is E91 protocol, which employs entangled qubits for key distribution. Alice generates a pair of entangled photons and sends one photon from each pair to Bob. And hence, the measurements are correlated due to the entanglement of both the bits. Then Alice and Bob compare the results to detect the discrepancies and derive a stable and a secure key. These are the attacks which commonly pose threats to communication systems. The first one is man-in-the-middle attack. This attack occurs when an attacker secretly intercepts and potentially alters the communication between two parties who are directly communicating with each other. The second one is denial of service. It aims to basically disrupt services by overwhelming the system with excessive requests. It causes slowdown. The third one is brute force attack, which primarily aims to gain unauthorized access to a system by trying all the possible keys and passwords. The fourth one is the replay attack. A replay attack works more in classical system, which involves intercepting and retransmitting the data, basically copying. In quantum states, this can't be copied due to the no cloning theorem, where each and every key is unique. The attackers could potentially store and retransmit associated classical information to the quantum states. Now the proposed system, the first part of the proposed system is the BB84 protocol implementation to create a secure key. Alice and Bob both create random bits of zeros and one and encode them into different polarization state, which we call bases in this case. So they compare the bases publicly after they take the measurements, and the bases which match with each other, they append the results to the key. Hence, a secure key is generated by implementing the BB84 protocol. The next part of this phase is that the obtained secret key is utilized to safeguard communication between Alice and Bob by the use of symmetric encryption algorithm like AES-128. Additionally, to ensure the authenticity of the transmitted data, MAC ID verification and timestamp validation is utilized. To date, there is no evidence of anyone successfully breaking AES algorithm, which is capable of handling different key sizes 128, 192, and 256. The security testing on the proposed system is done as follows. Man-in-the-middle attack, the defense mechanism used is that AES encryption ensures data packets remain encrypted and indecipherable throughout the transmission. The second one is denial of service attack, by ensuring that the keys are secured and generated at every run of the program. Frequent renewed, that is, the system minimizes the risk and the impact of DOS attacks. Brute force attacks, when the key is generated using the BB84 protocol, the randomness and security in QKD reduces the risk, making brute force attacks practically impossible. For example, if we generate a AES key of 128 bit, there can be 2 raised to 128 probabilities of finding the key, which makes it difficult for brute force to work. There are certain advantages of our system. Quantum generated keys ensure highly secure cryptographic keys, enhance data confidentiality, and advanced measures guard against MITM, DOS, and brute force attacks. There are, of course, certain limitations because insights for simulations may not capture real-world complexities. And the second one is early-stage quantum tech faces stability and error correction issues. Key generation or distribution overhead may affect performance in large networks. The future scope is experimental validation, which will focus on real-world implementation on real quantum hardware to assess performance, scalability, and reliability. Developing secure data exchange network, which basically means developing quantum secured networks. Interdisciplinary collaboration among quantum physicists and cybersecurity experts to advance quantum secured communication systems. These are the references used. Thank you so much.
Thank you, Sai, for your wonderful presentation. Is there any question for Sai about her presentation? Okay, so maybe there's no question. So announce the name of Brinda Ghosh is presenting her paper now. Brinda,
Yes,
please.
sir. I'm just sharing the screen, sir.
Yes, please.
So it's visible to you?
Yes, it is visible.
Yes, the title for the presentation which I have choose the blockchain-based e-voting system for secure and transparent election, which is the paper ID of 283 by the authors Vrinda, myself, and Himanshu Gupta from Amity University, Noida. First of all, I want to discuss the objectives, why I choose this topic. Basically, to introduce the concept of blockchain-based e-voting system in this current scenario, because blockchain is a popular technology that we are using currently, and mainly to explore the need for secure and transparent election in modern democracies. We know that elections held after 5 years. We know that the general way of election is coming, and after every 5 years it's held. So to modernize it, I just to explore it and also introduce this concept, mainly to discuss the potential benefits of implementing the blockchain technology, how it will enhance more and it will benefit our Indian democracy more, and to outline the challenges and considerations associated with developing and deploying blockchain, because in EVM machines there are some of the pros and cons will happen. So how to tackle the challenges and considerations. So I took that topic. So to propose the recommendation for the successful implementation and how the blockchain and the adoption of blockchain-based e-voting system, how it will help more. So going through the introduction, we all know that elections are served as the cornerstone of democracy. Without election, we can't choose our any leader or anything else. So by ensuring the representative citizens' voices in governance, we know that the traditional voting methods are susceptible to various vulnerabilities. In old times, we use ballot papers. Now, like EVM machines are included. So mainly in past times, they have included fraud type or tampering or inefficiency in that. So in recent years, there has been growing interest in leveraging blockchain technology, because blockchain, we can say that it is more secure because block of codes are happen. So data is secured more in that, so we can develop a secure and transparent voting system like that. So for this presentation, I aimed at delve into the potential and effectiveness of implementing a blockchain-based e-voting system. So throughout this, I will discuss the feasibility, benefits, challenges, and recommendation for how I implement this blockchain-based system for secure and transparent election. Going through the next part, how the proposed techniques which I used in that, mainly for the blockchain integration. Integrating the blockchain is mainly also a difficult part, also a challenging part for me, but it's somewhat a interesting part for because it provides you the tamper-proof and transparent voting records. Mainly, I can say that it is my final project of my college time. So yeah, it's helped me to gain knowledge about the blockchain and many things apart from that. And secondly, I use the cryptography. Basically, this is the main and vast thing we are using that because utilize the encryption techniques, digital signature, many of the hashing techniques for voting, for securing the voting data are useful in that. And thirdly, I use the end-to-end verifiable voting, end-to-end encryptions for the voters independently verify their votes, and all the privacy of the voters are secured in that. Second, next I use the multi-factor authentication, which is in current generation, which is the most secured privacy. We are using multi-factor authentication in like any of the field we are using, like Insta, we are using like any Facebook, WhatsApp, all in that multi-factor authentication we use. So implementing this mechanism to verify the identity of voters before they can cast their vote is the main important thing I can integrate in that, I can say that. And continuous monitoring and security updates, like if we need updates after some time or some changes in that. So continuous monitoring in that can help for the potential security threats and vulnerabilities we are often used to. Moving to next part, the phases which I divide for that paper, like how the project is evolved like that. So firstly, I have provided the unique digital identity for voters, like each voter is assigned with a unique digital identity for particular individual voter. So this identity ensures that secure voter identification will be there, and which prevents fraud. Because if we have a like original identity and a original origin and identity of voter, so we can why we can assign a unique digital identity of that voter. Next, recording votes on the blockchain. If we have the identity of the voter, so how we can vote? So when a voter casts their vote, it is recorded as a transaction on the blockchain. So like one participant one voter comes, so he cast his vote or her vote in that. So unlike traditional paper ballots, we know in the past times we use that, so which can be tampered with or lost, or blockchain records as a permanent and verifiable technique for in that case. Nextly, privacy and anonymity. Cryptographic methods protect voters' privacy because there are many mechanism, hashing techniques, many things that you have used for the encryption of methods and for the privacy of the voters. And voter can cast their votes without revealing their identity. They have their own individual identity of that, so their privacy is more secured. So nextly, the verifiability and integrity. Mainly the blockchain I use because of the verifiability and integrity of election results, because many of the voters cast their vote and we want that the result is verifiable, and from there is no threat and there is no mishappening there, or there is any fake counting. So for that I use the verifiability and integrity of the blockchain for the results, and every vote is traceable and the entire process is transparent. So there is no any chances of cheating, fraud in that. Lastly, the challenges and solution I encountered, that voter and identification authentication. Managing voter identification authentication is critical, because if their duplicate voters, so we have a breach in our system and there is double counting in that. So it is the main challenge that have uncounted, and blockchain securely links voters to their digital identities. So this is the main solution I have generated for that. Nextly, this is the accessibility, ensuring that all voters can participate regardless of their technical expertise is essential, because there are a number of people who can't vote because of some work, because of some and any issue of there. But in our democracy, we want all the who are 18 plus can vote without any hesitation or without any work of that. So while sitting in a home, they can cast their vote and can participate in that. So for that, it is essential. It is have user friendly interfaces, scale instructions are necessary for that. And lastly, the network latency and scalability. We know that there are some maybe a technical issue or network issue, but blockchain network must handle a large number of transactions during the election. So optimizing network performance being the most challenging part in that. So tackling with that is also a fun part of that, I can say. Lastly, the benefits I want to discuss, like some of the key benefits and feature it make more advanced, like security. We can say that blockchain overcome the security of shortcomings of traditional voting systems we are using. Transparency, if the entire process transparent, the result are also transparent and publicly accessible without any threats and fraud and cheating in that. And privacy, as I use blockchain, so privacy is secured and protected and are in authenticated for that. And verifiability, so anybody in that vote in that system can verify the election result with verifiability and no anonymity in that. Oh, thank you, sir. That's all I have for that presentation. Hello.
Yes, thank you, Brinda, for your presentation.
Thank you, sir.
Now I think so. Manjunath is also ready for this presentation.
Yeah,
Yes, please, you can go ahead.
now am I audible?
Yes, you're audible.
Yeah. Good morning, all. This is Manjunath from KLA Technological University. So now I'm going to present my paper on AES CBC implementation on resource constraint platforms, a case study on Raspberry Pi and Cortex M3. So giving a brief about my paper, in resource constrained devices such as Raspberry Pi and Cortex M3, the implementation of the algorithm, the AES CBC, is discussed, and it addresses the problems like low processing power and memory while concentrating on effective encryption. And you can also see the trade-offs between power consumption and memory use, and also the performance optimization within these platforms. So it overall it offers the information about safety of AES-128 into practice on low resource platforms for low processor scenarios. So this is exactly how the algorithm works. Here the plain text which is given as input, with the help of key and the algorithm, we may obtain the ciphertext at the end. So particularly we are we are using this AES algorithm because of its confidentiality and authenticity, and also the complexity. So this is the proposed framework where we are using this algorithm on the development boards, the platforms of such as the Raspberry Pi and Cortex M3. Further, we'll proceed with the side channel attacks. So what is the main motivation of this project? Okay. Our main motivation of this project is to implement the AES CBC 128 on these dedicated platforms, the Raspberry Pi and Cortex M3, and also understand how the algorithm works. So these are the objectives. Where starting with the testing and validation of algorithm. Here we'll perform various tests and experiments so as to ensure the algorithm is working properly, and we are getting the dedicated outputs for particular inputs. followed by testing. There is electromagnetic analysis, and where we'll capture the electromagnetic waves which are emitted as a part of leaks from these boards, the Raspberry Pi and Cortex M3. Further, we'll proceed with the evaluation and the optimization of the implementation. So, what is AES? It is advanced encryption standard. It is basically widely used symmetric algorithm, and it is a type of block cipher. And it is also better than a DES because it exceeds the DES in terms of strength, complexity, time taken, and many other factors. So here the key sizes varies from 128, 192, and 256. Coming to the encryption of AES algorithm, there are totally 10 rounds going continuous for 128-bit key, and there are majorly 4 steps, namely substitution bytes, shift rows, mix columns, add round keys. Knowing in depth in a more better manner for substitution bytes, here each byte of the data block is the plain text block, is replaced with the another bytes. Okay. Next, coming to the shift rows, here the rows of data block shifted cyclically by different offsets. And in the mix column, the columns of data block, nothing but the columns of plain text is mixed by multiplying with a fixed matrix. And last, the adding the round keys. Here it is the last step for the further proceeding to the next round. It is the last step where the data block is combined with the round key, and also it is derived from the original encryption key which we have used in the beginning. So we are using the CBC mode compared to ECB. It is because of it also outperforms the ECB in terms of security standards and is also more secure. And as in the diagram, you can see the output. Initially the plain text is solved with the initialization vector. So to start the process, we need the initialization vector where it is solved with the plain text, and the output of this is again solved with the plain text to get the another new cipher block. So this process continues for 10 rounds. And coming to the attack part, there are 3 different types of approaches we can go. As this is concerned towards automotive security, we are more focused towards the third part, the electromagnetic field attack. The first one is power analysis attack, where we can measure the power consumption of the particular device, and we can easily interrupt we can easily interrupt the device. The second one is the timing attack. We can also measure the fluctuations, we can also measure the fluctuations taken for the execution of the whole algorithm in the device. So one cannot place these two types because one cannot place the circuits and we cannot perform these all uh, attacks. So we are going with the electromagnetic field. So this is how we have implemented the Raspberry. We have implemented the ES CBC, as there were standard ISO standards present for these 2 boards. We were able to generate the ciphertext for particular input plain text. So capturing the electromagnetic radiations, that is nothing but the leaks from these 2 boards. So mainly the H probe. H probe is playing a major role in this scenario, where we are capturing the the electromagnetic waves. As H probe is an electromagnetic sensing device, it helps to capture the electromagnetic leaks. So this is the digital storage oscilloscope where we have where it is used for where it is used for viewing the spikes which are obtained from these 2 boards. And there is a small video of this demonstration. As you can see, this is the spikes. These are the spikes which are obtained through the H probe from the Raspberry Pi, and this is the H probe. You can see the demonstration video. So this is the Raspberry Pi, and this is the Cortex M3 board. And for the particular plain text, we are able to generate the we are able to generate the the ciphertext for the given plain text. Same goes for the Cortex M3, where we were able to obtain the plain text with the ciphertext as our output. And yes, yes. Coming to the results, we were able to approximately from these two boards with the help of HProbe, we were able to capture around 20,500 samples, data points, at a time from each of the boards. After plotting into the graph, we may see the observation that how the both the boards are behaving with these CSV plots. Yes, coming to the conclusion, we were successfully able to implement this algorithm on these two platforms and also demonstrating its robustness. And to 20,000 traces of EM radiations from the boards were captured. And yes, for future scope, we may come across the chip whisperer tool, which is more relevant, and it also helps to capture the traces on these systems and also helps to obtain the key specifically for AES-128. And with the help of chip whisperer, we can understand the side channel vulnerabilities more better in a more better manner, and also helps in improving any of the cryptographic systems which can be used in future. Yes, that's all from my side. Thank you.
Thank you very much for your wonderful presentation. Is there any question for the presenter? From the other presenters, if you have any question, you can ask. Okay, so that means
Thank you.
there's no question.
Thank you.
Thank you, Manjuna, for your presentation. Now, moving forward for the next presenter. Next presenter is Abiel Varela Ferreira, and she's going to present on navigating the future, indoor navigation using augmented reality. Dear presenter, you may please start your presentation.
Yes. Is my screen visible?
Yes, it is visible.
Okay. Good morning, everyone. So I guess we've all been there, navigating an unfamiliar grocery store in search of a particular item, or constantly being redirected to a different room in an administrative complex while initiating the process of a license or any other official document. Frustrating situations, right? But imagine this. You walk into a bustling airport, and instead of fumbling with these blurry maps and unreliable GPS, you just raise your phone and there are arrows directing you effortlessly to your gate. Our project, that is, Navigating the Future, indoor navigation using augmented reality, is here to make these fantasies a reality. But before diving into the specifics of the project, I'd like to talk a little bit about why we embarked on this project. So the project idea arose from a common issue faced by most of us, that is, of being led astray by a subtle deviation on Google Maps, which takes you over the flyover instead of the service road beneath. So we recognized this gap in the existing applications and thought, why not provide a solution which prioritizes the user's perspective instead? So buckle up, because we're now going to dive into a solution which combines efficiency, affordability, and a thrill of navigating indoor spaces like never before. So let us now talk about what we did in order to bring our concept into reality. So we began by replicating the physical environment into the virtual space. To do so, we used the 2D floor plan and placed cubes over it to create a 3D model of our college. Followed by, we set up QR codes in each room. These QR codes would then decode to the name of the room, which would then match to another predefined list, which consists of the position, rotation, precise coordinates, flow number, etc. And this entire process would help in relocating the user precisely. The user then has to select the flow. And to do so, there's a floor options button under which there are the different flows listed. Upon selecting a particular flow, the mini map would change to that particular flow.
The user then selects his destination under the navigation button by clicking on the drop-down button and selecting his destination. A turquoise line would then follow from the current position that is scanned to your destination, guiding you effortlessly. Let us now take a look at the demo of our project. So we first open our application called MapMate. They're currently at the ground floor of our college, as you can see. Now to bring about a change in the mini-map to that of the ground floor, we have to click on the floor options button and then select ground floor. As you can see, the minimap has changed to that of the ground floor. Now to relocate us precisely, we need to scan the QR code of the position that we are at. As you can see, the minimap has changed again. Now that we are precisely relocated, we select the destination under the dropdown, that is TPO. As you can see, a turquoise line is now guiding us to our destination. This line has to be then followed. The height of the line renderer is adjusted using the line height slider to counter the change of the height in the flow. Continue following the line, taking turns, and you finally reach your destination, that is the Training and Placement Office. Talking about the future scope of our project, imagine walking into a grocery store with AR technology, intricately mapping the entire store layout. It reorganizes your shopping list in order to calibrate the shortest path that you need to traverse in order to grab onto the different grocery items and spend the minimum amount of time. Another application could be if we could improve the point accuracy of our project, we could not just be directed to a particular room, but to a particular book or a particular document within the room. And this is useful in an administrative complex, school, college, etc. So it's time to shift our focus to what sets us apart. To begin with, our application prides itself on its autonomous functionality, that is, its ability to work in the absence of Bluetooth or Wi-Fi. Additionally, our system is designed to withstand obstacles, ensuring continuous operation. A standout feature of our application is its adaptive flow-level navigation capability. Moreover, our application efficiently replicates the physical environment using 3D models, optimizing both space and memory usage. Thank you.
Thank you, dear presenter, for this presentation. Is there any question for a presenter? Sanjeev sir, if you have any question for the presenter. All right, so maybe there's no question for anyone. So moving forward for the next, we have Tejas M. And he's going to present on side channel analysis and hardware implementation of AES CBC algorithm on ARTIX A7 FPGA development boards. Tejas, are you here? Tejas, are you available?
Yes, sir. Yes, I am.
Yes, you
Am
may
I
please
audible,
proceed.
sir?
With. Yes, you are audible.
Is my screen visible?
Yes, it is.
1 second, sir. Okay. It's Tejas, and my paper ID is 259. Briefing about the total paper is the increasing importance of data security makes the implementation of encryption methods on platforms with limited resource imperative. The Advanced Encryption Standard AES is a popular protocol for sending data securely since it provides different key sizes of different security levels. The implementation of AES CBC with a 128-bit key on systems with limited resources such as RTX A7 FPGA board is subject of case study presented in this paper. We ensure efficient encryption while addressing issues of constrained resources such as computing power and memory. Our implementation relies on performance optimization within these platforms' limits. Our study findings provide information on how to implement AACBC 128 on platforms with limited resources, allowing for safe communication in low processor scenarios. So coming to the project, it is the hardware implementation of AACBC and its vulnerability analysis. As the demand of hardware security is increasing in automotive domain, we are mainly focusing it on the automotive domain, the hardware security. The more threat is caused to the sensitive data that is present in the ECUs and other parts of the automotive domain. This is increasing the importance of the security. Thus, it is extremely important to secure the automobile software and hardware. So, what is a side channel attack? A side channel attack is performed on a hardware board that is we have taken as a Nexus A7, where a hacker can attack the board by various hardware analysis such as power, timing, or electromagnetic analysis. And then he can sniff out the data that is being present in the hardware board. So how does this work? When the input is given to the secured device and it is presenting an encrypted output, it provides a various methods of vulnerability such as power, timing, and electromagnetic field that can be used to sniff out the valuable data present inside the particular secured device. One second. So there are, as said, there are different ways of side channel attacks, that is timing attacks, power analysis attacks, and electromagnetic attacks. But we are, as it is mainly based on the automotive sector of the hardware security, so we are mainly focusing on electromagnetic attacks. So how is this electromagnetic side channel attack done? Basically, we need an EM probe that extracts the electromagnetic radiations coming out of this board, that is the RTX board, or any other part of the automobile ECUs, which captures the electromagnetic waves that has the data which is present inside the board. So then these EM waves that is being captured this board is then being sent from a digital oscilloscope, which is being recorded. As you can see, the spikes in the digital storage oscilloscope, they have been recorded, and these are the traces that are being recorded from the boards. These traces that are being recorded are then processed throughout the various machine learning machine learning techniques that is then used for retrieving back the key that is being used for the encryption algorithm that is being used in the device. So this is the whole process of how it is being done, the picturesque view. This is the simulation of encryption method in the development board. This is the Nexus A7 board that is being used. This is how the side channel attack was performed on the board. For validation, like the lower thing, the key, the ciphertext which is being seen here is being validated by the number of the 16 number of LEDs that is being projected on the board. Such as you can see in this picture, it is being validated through these LEDs. After this, as I said, it is being processed by the various deep learning models, such as we have shown it here. which provides the max key rank and the mean key rank for all the 7 of these. In conclusion, the AES in CBC mode is simulated, synthesized, and implemented on the target platform, that is Nexus A7 board. The proposed design was validated for different test cases, and also the side channel attack was performed on this same board with a successful implementation. 20,000 traces of EM radiations were recorded from Nexus A7 board each time. Multiple pre-trained models were run on previously available datasets for side channel analysis. Concluded that the HPROP EM wave side channel attack is not so powerful enough to get the key from SCA due to less accuracy. So we are continuing with the future scope of using the chip whisperer that is more efficient in tracing out the EM radiations from the hardware board. That's all from my side, sir. Thank you.
Okay. So, shall I ask a question?
Yes, sir.
Yeah. So, Mr. Tejas, what I understood from your presentation, that is the vulnerability analysis, and you have
Yeah.
implemented the hardware implementation of AES.
Yes, sir. Sure, sir.
And one of the parameter you have taken for your work, that is a side channel attack. So let me know what are the existing situation, the existing model, why this parameter you have chosen, where is the gap?
Yes, sir. The side channel attacks, that is basically sniffing out the data from the hardware boards through various hardware tech, such as the timing, power, and also the electromagnetic radiations, which is being emitted out from the hardware security boards, which is vulnerable. So analyzing this side channel vulnerabilities from this board and securing them is an important part for securing the automotive ECUs, which are being vulnerable in hardware securities. So this was the gap we were focusing on. Excuse me. Hello.
Yes, I think that's the answer you have.
Okay, sir.
Okay, thank you so much for your presentation. Moving for the next, we have Vijita Chitragar, and she's going to present on trajectory prediction of multi-traffic agents.
Yes,
Dear
sir.
presenter, you may please proceed with the presentation.
Yes. I'm audible, sir?
Yes, you're audible.
Myself, Vijita. I'm presenting trajectory prediction of multi-traffic agents. Here, introduction. Accident rates have been increasingly steadily. These accidents involving human errors, such as speeding, distracted driving, and impaired judgments. 90% of accidents caused by human error. Younger drivers, in particular, are often to found exceed speed limits, which is leading cause of road accidents. Autonomous vehicles are designed to eliminate human error. They are equipped with sensor camera that can continuously monitor road conditions, obey traffic law, and make split-second decision to avoid collision. So there is a need for accurate prediction. Our objective is to predict the future motion of a dynamic agents, and we are extracting the 3D features from our 2D images. These are the related works we have gone through. And we are using nuisance datasets, which has a 40,000 scenarios, and for particular location, it has 1,000 scenarios for 20 seconds long. Methodology. Here, firstly, we extract the 3D features from 2D images, and we the aerial view projection, and the temporal model uses these past revo motion and aerial wave projection to give a current and future tendencies, and future prediction aerial view uses the current, the future tendency, and give the future prediction, and the segmentation and future instances are done with the motions. Let us discuss how each and everything done. Next, the 3D feature extraction. Here, each camera at each past time step is processed using convolutional neural network. Imagine that a set of images that captured by different camera at particular time. Each image is processed to extract a certain features like edges, length, width, and depth. Depth, which mean how far each pixel is from the camera. And the output image has two tensors. Here, feature channel tensor and depth probability tensor. Here, C represents the number of channels and height of H represents the height of the feature channels. W represents the width of the feature channels. And here, D represents the depth probability, number of depth probabilities of the tensors. HE represents the height of the depth probability, and W represents the width of depth probability. Next, aerial view projection. These tensors, the feature channel tensor and depth probability tensors, are combined to create a comprehensive feature map known as the aerial view. Here, a particular ego vehicle, which consists of a camera, it gains a particular area. Here, each area is divided into dimension of 0.50 meter into 0.40 meter columns. Each column is gone through a extraction of a 3D features using a CNN. The 3D features are then sum-pooled with a vertical dimension to create an aerial view feature map. Next, a temporal representation. Here it is a method of using the past information of a vehicles to understand the present and predict the future. By using temporal representation, the self-driving car takes these past observations and actions into account to accurately determine its current state and make better decisions. Next one is a current and future tendencies. It predicts the future event based on the current observations. It has two distributions, current distributions and the future distributions. Next, the forecasting the future from an aerial perspective. It predicts the convolutional gated recurrent network is used for the forecasting. It will predict the future states. Segmentation and future instances and motions. These gives the output includes semantic segmentation, which identifies and categorizes different objects, and instant centeredness. Locate the center of each object. Offset measures the movement of an object. Future flow predicts the future positions. Metrics. Here, video panoptic quality is designed to access the system's ability to accurately detect and segment instance over time. It has two qualities, recognition quality and segmentation quality. This measures how consistently the system detects the same instances across different time steps. Segmentation quality, this evaluates the accuracy of instance segmentation. How well the system identifies the boundary of each instances. Here we VPQ, which is the formula of VPQ, video panoptic quality. It has a IOU, which means intersection overview. This measures the overlap between predicted objects and the actual object location. Higher the IOU value, the better the prediction. For example, let us assume that IOU has the value of, the IOU is the range between 0 to 1. So we assume that IOU is the value of 0.7, which means 70% the predicted object is correct. And this formula also includes the TPT. It is the set of true positive, which means these are the cases where the system correctly identify the object. And FPT, it is the false positive. This is the system incorrectly identifies something as an object. And false negative, which means it fails to identify an object. These all combines and gives the VPQ, video panoptic quality. Here results. Let us discuss a figure 2. A camera captures 6 different images at a particular time. Here, the front left, here we can see there is no cars in the road. So in this, there is no car detected and there is nothing. And in next front, there are 3 to 4 cars or different types of objects being detected. So here, 3 objects are detected, and we are the autonomous vehicle is predicting the future motion, which is nearer to the camera. See, we have yellow one, brown, and green. These 3 are detected, and the future motion also detected. Here, the farther from the camera, the object is detected, but the future is not predicted. For example, dark browner. Front right. In these images, we have detected 2 objects here, orange one and the pink one. The future motion also detected. In back left, the object is detected, but there is no road. So the object is also detected, and the future motion also not given in this image. And in back, there are several cars coming towards and going away from the camera. So these are detected here. Back right, here there is no car detected and there is nothing. So there is no detection in this area. Let us take another example. Here we can see in the figure 4, we can see there are cars, but there is no motion in this. So the in this resulted option, we are detecting the cars, but there is no future motion and there is no projection of these cars. So only the dark colors are given. Comparison with the other papers, our proposed model again, it is a table of comparison of IOU, intersection overview. We have achieved 59.4% IOU for short range, that is dimension of 30 meter cross 30 meter, and 36.7% IOU for long range scenarios, and improved our VQ values to 50.2% for short instances and 29.8% for long instances, indicating better temporal consistency and segmentation quality. Conclusion of the proposed model that predicted the future states of dynamic objects in the environment, the accuracy also increased from the other papers. Here we have increased 59.4 from the FIRI and FIRI static and fishing camera. The detected are 30.4, 57.6, 59.0, and our proposed model gives 59.4. We have increased our accuracy. The proposed model uses full spectrum single camera films for an aerial view and employs a variational distribution to account for future variations. And these are our references. This is my side. Thank you, sir. It's done.
Okay, sir, do you have any question for the presenter?
Yeah. So what are the improvements you have performed over the existing system? That is the first question. And
Yes,
second one is comparison with the Google Map. So how will you conclude your work with the Google Map?
Sir, we have gain accuracy of 59.4. We have also taken the FIRI paper, which is 59.0. We have increased our accuracy. We are increased from the learning rate for a particular observation. So we increase our accuracy from there. And sir, this is our map results. So I have explained this.
Yeah, comparative to the Google Map analysis, what improvements you have found out?
We have taken the scenarios and we have detected. We have not compared with the Google Maps.
Okay, fine. Thank you.
Oh, thank you, sir.
Okay, thank you, dear presenter, for your presentation.
Okay, sir.
Moving forward for the next, next we have Lakshmi, and she's going to present on vehicle license plate detection based on look only once and optical character recognition techniques. Lakshmi, are you here?
Yes, sir.
Yes, you may please proceed with your presentation.
Okay. Good morning, everyone. My name is Lakshmi Kautal. I'm from KV Technological University. Our paper ID is 347 and title of the paper is Vehicle License Plate Detection based on look only lens and optical character recognition techniques. So the world is moving towards automation. So there is increase in the count of vehicles and developing the traffic monitoring system. Where earlier a human agent was generally does traffic monitoring manually, which is very tiresome, time consuming and inaccurate. So vehicle license plate recognition system is very important for automation, where it takes optimum time and very accurate and more accuracy in identifying the license plate. This license plate recognition serves very important purposes in the many practical applications such as tolling, ticketless parking system, and identifying the stolen vehicles and many other applications. Objectives of our project is to compare the license plate recognition system with non-learning and learning-based techniques. Next objective is to detect the object algorithm of license plate with fewer or less false positives, and employing the optical character recognition for recognizing the characters. This is the literature survey of different research papers of different. They have used different algorithms such as MATLAB and DHMN and KNN, where vehicle license plate detection task is done mostly using pre-existing models of YOLO, the YOLO versions, that's such as versions are 4, 5, and 7 for license plate localization. And for character recognition, the algorithms used are template matching, CCN, and OCN. This is the dataset we have used. The dataset is taken from the RoboFlow, where it contains nearly 1800 training images and 100 test images. These images doesn't have any pre-processing applied for it. This is the proposed methodology where a captured image is given to the trained YOLO version of 8, where it localizes the license plate and the license plate is captured and recognized using OCR technique. The YOLO V8 model was trained using dataset, and license plate localization is successfully detected the license plate and drew the bonding bonds around them. Extraction of license plate is a procedure where using Python tools, the license plate is extracted or captured from the localized license plate, and the OCR, that is optical character recognition techniques, that it helps to recognize the characters, and it is computer readable digital text. These are the results obtained from the first image shown. First image shows that the license plate is localized using YOLO model, and next two images show that the license plate is extracted and it is recognized using OCR techniques and Python tools. This is the matrix obtained, where it is a confusion matrix where 50% of vehicle plates are correctly classified and rest 50% are misclassified as a background, and it perfectly identifies the background. And this is the precision confidence. Next figure shows the precision confidence curve, where the precision is improved. That precision is almost 1 at the confidence of 0.375 of the classes, where the confidence is increased. The conclusion is that the license plate YOLO V8 model accurately localizes the license plate and with lesser time consumption from the pre-existing models. And the OCR recognition performance is that it correctly recognizes the characters from the captured or cropped license plate. And some of the drawbacks of the OCR are sometimes it doesn't recognize the characters such as 4, 2, and 7. And this model can be further improvised using more datasets, and it is used for many other applications. Thank you. So that's for my presentation.
Okay, so Ms. Lakshmi, the project you have presented regarding the license plate recognition using the OCR. But you know, OCR technology is getting used since last 25 years on the toll booths. So what kind of special thing you have implemented? One thing. Second thing is that the current scope for improvement over the existing system is the time to recognize the license plate. So have you worked on that time complexity? Yes. Yes.
The latest versions of YOLO consumes more time. The version of YOLO, that is V, consumes less time compared to the latest previous versions of YOLO, and non-learning methods also uses more time, such as MATLAB and CCM. It uses more time, and the accuracy is very low. The accuracy of our project is improvised compared to the other projects, other techniques.
See, the more less improved and not improved are not perfectly the outcomes of the project. So can you elaborate statistically what percentage of the things, the time accuracy or the time consumed to recognize the lesson that you have achieved?
The accuracy of our model is 83.25%, whereas the non-learning methods such as MATLAB and all, this is only 76 to 78%.
Okay. And what about the time?
The consumption is less compared to others.
So you cannot elaborate statistically because less, more, this cannot be give the confidence what are the exact outcomes of the system. Okay, fine. Thank you.
That
Thank you.
we cannot do.
Okay, fine.
Okay.
Thank you.
Thank you.
Okay, thank you for your presentation. Now, the last announcement for the Shibu. Anyone presenting on behalf of him? Is there anyone who's going to present this paper on behalf of him? All right, so there's no one, he's absent. Okay, so as we have completed all the presentation in this session, I sincerely thank our authors for their excellent and presentation and their great contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you, and we, on behalf of the whole team, thank you for your support during this version and all the previous 8 versions of this conference. And we're really happy to have you all in the 10th version of this conference in 2025 Goa. Further, all the presenters will be getting their digital certificates through email within 2 working days. And all the papers have been already forwarded to the strangers. So I request all to please cooperate with the team ICT4SD 2024. I also thank our session chair for being the chair of this session. And so there is one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation. Sanjeev sir, this is for you to be a chair.
Okay, thank you, sir. Thank you.
Thank you, sir, for your valuable presence. And now at the end, I request all of you to turn on your camera so we can capture good memories of this virtual conference. I request all, please turn on your camera. Thank you all for your wonderful presentations, and thank you, sir, for your presence.
Yeah, thank you. Welcome.
Thank you. And have a nice day and take care.